If I say that what you are seeing right now doesn't actually exist, would you believe me? You certainly wouldn't believe it. Our scientists didn't either. But after countless experiments, something changed. They discovered a truth so profound that it has altered how we understand reality itself. What they found was simple yet terrifying. Reality isn't always continuous. It's not something that just exists on its own. It's created by you, the observer. And the world we live in now? It might be just one version out of many. This isn't a ghost story. This is quantum mechanics. Welcome to my channel, The Fifth Door, where today we dive deep into a concept that might just change the way you look at everything. The world you see may not be what it seems. Chapter 1. The world isn't as solid as you think. Let me share something strange with you. The things you see with your eyes may only exist at the moment you observe them. It's not just philosophical speculation. This is a Nobel Prize-level scientific truth. The reality we encounter every day may not be the reality we think it is. So what exactly is quantum mechanics? Simply put, it's the study of the smallest building blocks of the universe. Look around you. Your cup of coffee, the table it rests on, the chair you sit in, the street outside, even airplanes flying overhead. From a macroscopic perspective, these things appear solid and continuous. You can see them, you can touch them, but all of them are made up of countless smaller components. Molecules, atoms, electrons, particles so incredibly tiny, it's almost beyond imagination. Imagine the pixels on a high-resolution screen. The universe is constructed in much the same way, just on an unimaginably small scale. Think about the video you're watching right now. It looks smooth and continuous, doesn't it? But in reality, it's made up of about 30 still frames per second, flashing by so quickly your brain perceives them as a continuous motion. What if the world itself works like this? What if the things you see, chairs, trees, clouds in the sky, don't exist in a constant state, but rather flicker in and out of existence, appearing only when you observe them? This isn't a random idea. Scientists studied the microscopic details and discovered something that left them astonished. The real world isn't truly continuous. It jumps. It flickers. It behaves more like static or sparks, appearing moment by moment, bit by bit. And it all began with a question most people wouldn't have thought twice about. Why does metal change color when heated? In 1901, a German physicist named Max Planck found himself obsessed with this mystery. Classical physics couldn't explain why metal glows red, then yellow, then white as it gets hotter. Planck tried every solution he could think of, but nothing fit. Finally, in desperation, he made a radical assumption. Energy isn't released smoothly. It comes out in tiny chunks called quanta. To visualize this, imagine turning on a faucet. The water looks like a continuous stream. But what if, instead of flowing smoothly, the water was actually made up of countless tiny droplets appearing one after another so quickly that it looks like a steady flow? Planck's idea was just as radical, and just as groundbreaking. His theory explained the problem perfectly, winning him the Nobel Prize. Albert Einstein expanded on Planck's work and earned his own Nobel Prize. And with that, the door to a completely new world had been opened. Chapter 2. The Double-Slit Experiment. Now we arrive at one of the most famous and strangest experiments in all of physics. The double-slit experiment. Imagine standing in front of a wall with two narrow slits cut into it. You have a gun that shoots bullets at the wall. Naturally, you'd expect two lines of bullet holes behind the slits, matching the shape of the slits themselves. That's basic physics. Physicists recreated this setup, but instead of bullets, they fired electrons, the tiny particles that make up atoms. One by one, electrons were fired at the two slits. But what they saw wasn't two neat lines. Instead, The wall showed an interference pattern similar to the ripples created when you throw a stone into a pond. That didn't make sense. Electrons should behave like particles, not waves. To investigate, scientists slowed everything down. They fired one electron at a time. It should have been simple. The electrons go through one slit or the other, right? Yet the same interference pattern appeared. How could one electron interfere with itself? Puzzled, the researchers decided to watch the electrons directly. They installed detectors to monitor which slit each electron passed through. And then came the truly baffling part. When observed, the electrons behaved exactly as expected, like particles. They formed two neat lines on the wall. But when unobserved, they reverted to acting like waves, creating that same interference pattern. It was as if reality itself changed depending on whether someone was watching. When observed, the world behaved predictably. When unobserved, it acted like a completely different system. Reality seemed to flicker between two states, one for the observer and one when no one was looking. This experiment forced scientists to confront a deeply unsettling idea. Perhaps the world doesn't exist independently of the observer. Maybe what we see as solid reality only materializes when we choose to look. Chapter 3: Schrödinger's Cat and the Many Worlds Theory. To highlight just how strange quantum mechanics is, Austrian physicist Erwin Schrödinger proposed a thought experiment in 1935 that has since become legendary. Schrödinger's cat. Imagine a sealed box containing a cat, a radioactive atom, a vial of poison, and a trigger mechanism. The atom has a 50% chance of decaying in 1 hour. If it decays, the mechanism breaks the vial, releasing poison, and the cat dies. If the atom doesn't decay, the cat lives. According to quantum theory, until you open the box, both possibilities coexist. The cat is simultaneously alive and dead. This seems absurd, but it's a direct consequence of the same quantum rules seen in the double-slit experiment. Schrödinger wasn't trying to claim cats can actually be both alive and dead. He introduced the paradox to show how strange quantum theory really is. Yet no one could refute the logic. And so came an even bolder explanation: the many worlds interpretation. Proposed by Hugh Everett in 1957, the many worlds theory suggests that every possible outcome actually occurs in different parallel universes. When you open Schrödinger's box, in one universe the cat is alive, in another it's dead. The universe splits the moment the observation is made. Everett wasn't just an eccentric dreamer. He was a Princeton PhD student with an IQ estimated at 190, famous for memorizing entire scientific papers. But his idea was so radical that it was ignored during his lifetime. Disillusioned, Everett left academia and worked as a nuclear missile trajectory engineer for the U.S. Department of Defense. He died young, at just 51 years old. Years later, his son Mark Everett, frontman of the band Eels, discovered his father's forgotten papers and realized the truth. His father wasn't a failure. He was a visionary far ahead of his time. Today, Everett's many worlds theory has become part of mainstream quantum physics. Institutions like NASA and Google have incorporated its ideas into quantum computing and simulation research. Chapter 4: Beyond Reality. Quantum Entanglement. If all of this sounds like science fiction, consider this. Modern experiments strongly support the many worlds view. One key piece of evidence is quantum entanglement. In entanglement, two particles become linked so that whatever happens to one instantly affects the other, no matter how far apart they are. This phenomenon defies classical physics and has been tested in countless experiments. The results confirm that quantum mechanics isn't just theoretical. It's real. It affects the very fabric of our universe. Quantum entanglement suggests that the universe is more interconnected than we ever imagined. It's not just a set of isolated objects moving through space. It's a web of linked events and possibilities, branching into countless realities. Conclusion: reality is not what you think. Quantum mechanics forces us to face ideas we once thought impossible. Reality may not be fixed. It may flicker, jump, and split into infinite versions depending on your choices. And now, I leave you with this final question. If reality only exists when observed, what happens when no one is watching? Are we living in just one of many versions of the universe? Let us know your thoughts in the comments. Do you believe in the many worlds theory? Or do you think consciousness creates reality itself? Thank you for watching my video. Until next time, keep questioning everything you think is real.